evening to everyone. Welcome back to the third session for Python for Data Science. This is a live interactive problem solving session. I am Sedu Vinayagam, a PMRF PhD scholar at the Department of Civil Engineering in IIT Madras. Okay, so let's get started with today's session. So let's quickly look at what was covered in the lectures for week 3 of this course. So in this week, we were looking at how to load the data from files, and how to manipulate the data and process this. So this is important before we get into the modeling process, right? So, because the primary input for the models would be the data, right? So we were looking at how to read the data, and within this, we were looking at how to read multiple different formats of data, because generally there are different formats in which the data will be available to us. And so the common formats that we will generally deal with are CSV files, which stands for comma separated values, and Excel worksheets that you all may be all familiar with, and also plain text files. And we were also looking at the different delimiters. So delimiters are nothing but the characters which separates two values, right? So the character which says this, which tells us that one value is different from the other value within that text file or the CSV or the Excel file that we are working with. So different, again, file formats use different delimiters. And again, the common ones are commas, which is what we will use in the comma separated values. However, other delimiters such as white spaces, tab spaces, semicolons are also used. And then we also looked at how to set index column. So index is nothing but a label for each row in our data, row or observation in our data. And also when we are working with data from real world, we'll often have some values that are missing, or some values that represent that we do not have the observation for that particular record. So in those cases, we will encode it with a particular special character, or in some cases we will leave those as blank cells. So how to specify these kind of special characters to be treated as numbers that are not available. So those functions we are looking at when we are reading the data. And in particular, we will be working with a library called as pandas, so which is very powerful and very popular for working with these kind of spreadsheet or the tabular data that is most common in data science. And in particular, it has a data type called as data frames. So data frames are nothing but two-dimensional ways of organizing the data. So you'll have different columns and then different rows. Okay, so each column is one particular variable in our data, and each row would be one observation or record in our data. So here we are looking at what are the different methods that are available in the pandas data frame for reading, for copying, the making copies of the data frames, right? When you want to change something but we do not want to change the original, so we have to make a copy. So we saw how to do that. Again, similar to what we saw in the last week with respect to the sequence data types, where from a collection we wanted to get a subset. So we used techniques like indexing and slicing. So the same can be applied on data frames as well to get a subset of rows or a subset of columns. So that's we looked at how to do that. And then we also looked at what are the different data types that are supported by pandas. So in general, one thing you have to remember is each column in your data frame can contain only one type of data. So similar to how we saw in arrays as a sequence data type, arrays can contain only a single data type. So similarly, each column in the data type in the data frame can contain only a single data type. However, different columns can have different data types. One column can have integers, another column can have floating point numbers, another can have strings, and so on. But within a single column, all observations or all rows should have a single data type. And then we also looked at how to look at these, which column is containing which kind of data, how many observations are there. So those kind of summary information, how to retrieve once we have read the data, how to find out the number of unique elements. And then we also looked at how to convert from one data type to another data type. So when we want to replace some values within a particular variable, how to do that, and also look at how many values that are missing in our data. So then we also looked at the control flow statements and functions. So here, how do we execute a particular statement depending on a condition? Say if you want to, execute some particular statement, say a equal to 5, but you do not want this to be executed all the time. So depending on some condition, if that is true, you want this to be executed, or if this condition is false, you want something else to be executed. So those kind of logics, how do we code such kind of logics? So control flow statements help us to do that. So this is achieved using the if, elif, else commands or statements. And then we also looked at for and while statements. So these for and while statements are called loops. So a loop will allow us to execute a single or the same set of statements multiple times. And then we also looked at functions. Again, functions are reusable pieces of codes where you define a particular logic that works on a given input, and then you can repeatedly call that logic by varying your input parameters. So we looked at that. And then we also looked at data visualization. And this is also a very integral part of data science and data analytics. So you should understand your data, as well as you will be required to present your results that you get from your model. So for these, the data visualization skills are very important. So we looked at two libraries in particular, that are matplotlib and cbon. And we looked at different kinds of plots like scatter plots, bar plots, box plots, and histograms. So the type of plot that you choose depends on the type of data that you have and the kind of analysis that you want to perform, and the inference that you want to make. So that we covered. And then finally we were looking at the missing values, right? So even though we looked at earlier how to encode the missing values in our data, so here we were looking at how do we go ahead with data that has missing values, how do we treat it so that we can use those observations in the model. So in particular, we were looking at three types of treatment. One is mean treatment and median treatment. This is applicable for variables that take continuous range of values, like integers and floating point numbers, which take continuous values. And we also looked at mode treatment, which is more suitable for categorical data, like which is like different kinds of categories you have, right? So these are the concept that we were looking at in week 3. So I'll now briefly give like a tutorial on what we were doing with this, or how to deal with this. So as we saw last time, I'll give this tutorial using the Python and Python notebook. So, yeah. So as we saw last time, how to install and Python notebook. And I'm using the same thing. I'm using the Jupyter notebook here. So you can follow this with, again, Jupyter notebook or Spider or any of the IDE. The same codes will work. However, notebooks will allow me to demonstrate this better, because I can show the output immediately after the code runs, and it will also be saved together, so I can share this later. So I'm just importing all the libraries that I will be needing in this particular session. So in particular, I'll be using the array data type. So this is one of the built-in sequences. So from the array library, I'm importing the array class that I will be using. Then since we are going to look at visualization, so I'll be using the matplotlib as well as the cbon libraries. And then also we'll look at the numpy array. So because last time when we are looking at the sequence data types, so we did not touch upon numpy. So we'll quickly look at numpy data type. And then also we'll be using the array pandas data frames. So I'm importing the pandas library as well. So one thing you may see here is we are using after some libraries I'm using as, and then I'm putting some name, right? So import matplotlib.typeplot as plt. So what this portion here refers to is called an alias, right? So which means I'm importing this library, and then I'm storing it using a different name. So instead of every time I want to use some method or function that is available within this library, I can use the shorter name that I have given. Instead of typing matplotlib.pyplot every time, I can just type plt, which will give me the same thing, right? So this is just for convenience. We will usually, create aliases for some libraries, and there are, conventional way that people use some libraries. For example, NumPy, you will see in most examples, most people will import it under the alias NP, and pandas under the alias PD, and cborn under the alias SMS, right? So these are some of the unsaid rules that people follow, but you are free to use any other alias that you feel is more convenient for you. But these are general alias that people use for these libraries. So once we have imported the libraries, so first I'm creating a list of values as we saw last time. So we use the square brackets to define a list, and then we give the values inside it that's separated by commas. So I'm just creating a values list. So it has 5 integers, 1, 2, 3, 4, and 5. Right. So last time we saw how to create arrays. Right. So for creating an array, what do we do? So we call the array function, and then we have to specify the type of data that it is going to contain, and also remember that arrays have to contain only a single data type, right? So therefore we have to say what is the type of data that this array is going to contain. So it is going to contain integer values, so I'm using the code I, and then I'm specifying the values that the array has to contain, right? So I'm using the variable values which we created earlier. So this gives me an array of integer data type that contains 5 integers, right? So this is what we saw last time. And a quick tip is, if you don't know or forgot about some particular built-in method or object, or some library that you have imported and you have forgot, if you want a quick reference to help on that particular object or library, you can use the help function in Jupyter Notebook. You can type help and then pass the name of the library or the object or the built-in function that you want help with, and it will give you a quick summary of about that particular object. For example, here I have called the help on the array class, and then it tells me a quick summary of what this class is about, right? So this is array represents the basic values and behaves very much like list, except that the type of object stored in them is constraint. So what is that constraint? It is the constraint is that it has to be of single data type. And so we use the code I to specify that we are storing integers, right? So but there are other types of data that you can store as well. So depending on the how big the integers that you want to store, right? So you can use different codes which will support up to different ranges of the integers that you can store, and whether you can use signed integers or unsigned integers. So you can pick the type of code that you want. So this is a quick way of getting help on different objects that are available in Python. So it also gives you a summary of the different methods that you can use on the array data type. Right, a quick one-line summary of what that function does. Right, so if you want more detail on a particular function, so you can use array.append, and it will give you help on that particular method. So for append, the input that it takes is a particular value, and it will add it to the end of the array. So this is a very quick and a helpful way of finding about different things. So same thing I can find it for the list class, right? So list class gives you a mutable sequence as we saw last time, right? Lists are mutable, and if we don't give any input, it will just give us an empty list. And what are the different methods that are available on the list function, list object? So those are also given, right? So this is a quick way of finding about different objects. Okay, so now let's get into how to work with NumPy arrays. Okay, so NumPy arrays are very much like the built-in Python arrays, but with some differences, right? So to create a NumPy array, so what we will do is very similarly to how we created array. So we are going to call the array function from the NumPy library. Okay, so because we imported the NumPy library under the alias NP, so we can use NP instead of calling NumPy. So np dot array, and then we just pass in the values. Okay, and then that gives us an array of NumPy array of the values that we have, and I'm storing it in the variable np array. So if we see, we are getting a very much similar output, right? So array of 5 values 1, 2, 3, 4, 5, which was similar to what we had here. So the first difference that you may notice is when we created the array, we told explicitly what is the type of data that we were storing, right? But when we created this NumPy array, we did not specify any data type, right? So this is possible in NumPy arrays because NumPy will detect what is the type of data that you are passing in, and it will choose a type for you that is most suitable for the data that you are storing. So in this case, it has auto chosen what is the type of data that it has to use to store these numbers. So if you want to know what type of data that NumPy has chosen, so we can call the dtype attribute, right? So nparray.dtype. So this is an attribute that is available with the NumPy array. So that tells us that it has chosen int 64. So 64 represents the number of bits that is used to represent a particular value. So 64-bit integers is the type of data that NumPy has chosen for the values that we give. But it is also possible for us to specify what is the type of data that it has to choose. So you can explicitly tell. So even though our values list contain only integers, we can force the array to store these as floating point numbers. So how can we do that? So along with passing the values, we can also specify the type of data using the dtype parameter. So we can say dtype is equal to np.float32, right? And then we'll see the output. So here we see that even though the values that were passed in are integers, the output is now floating point numbers, right? So it has used the dtype as float32 instead of int32. Okay, so that's how you can explicitly specify a data type for your NumPy array. And now when you want to know what is the size or the length of your array, you can use the length function as you would use with any other sequence, right? Length of values we will use when we want to find the length of the list. In a similar way, we can use the length function to find the size of a NumPy array, right? So here length of NumPy array 2 gives us 5 because it contains 5 values. But there is another function, another attribute on the NumPy arrays called shape. And what the shape tells us is that the length of your array on along each dimension of your array, right? So here this is a single dimensional array, right? So we have only one dimension, and the length along that dimension is 5, right? So we get a 5 comma, right? Because it's a single dimensional array. But as with arrays, we can also create multi-dimensional arrays using NumPy. So in that, if you have multiple dimensions, you will get the shape or the size of the array along each dimension separately. So that's what the shape function will give you. And you can also change the shape of your array using the reshape function. So what we have is a single dimension, right? So 1 2 3 4 5. But what will happen if I tell it to reshape it in this way? So what I'm telling is reshape it so that it has 5 elements on the first dimension, and I'm giving -1. So -1 means the dimension, the size of the dimension, the size of the dimension specified by -1 will be automatically detected based on the size of the array, right? So -1 will be replaced with the size with a suitable size. So in this case, the -1 will be replaced with 1 because we in total we have only 5 elements. So if I use 5 elements in one dimension, the other dimension cannot have anything else. So it will be an NumPy array which will have 5 rows and 1 column, right? So because we have only 5 elements and we wanted 5 rows, so we can have only a single column of data. So you can see that now instead of being a single list of array, it has become a two-dimensional array where in one dimension we have 5 elements, that is 5 rows, and the second dimension we have only one element, so that is only one column. So if you look at the shape now, instead of being 5 comma, it is now 5 comma 1 because it has now become a two-dimensional array instead of one-dimensional array. Right. So next, let us create another array. Okay. So here, instead of passing in a list of values, I'm passing in range. right? So if you recall, what does range give us? So range allows us to generate a continuous sequence of numbers, right? So range of 1 comma 7. So it will give us a range object. So if you want to look at what are the values, you can explicitly convert it into a list, right? So it gave us numbers from 1 to 6. Why? Because I'm saying start from number 1, right, and generate numbers that are less than 7, right? And each time we are saying incremented it by 1, because the third parameter, step parameter, tells us how much we have to increment each time, and by default it is 1, right? So starting from 1, we are incrementing by 1 each time until as long as we are less than 7, right? So this gives us a number 6 values, and so I can directly pass that range output of the range function to the numpy array, and then I can create a array like this. Now what happens if we reshape it using by specifying the size as 3,2. So here what are we saying? So we are saying convert this array of values into two-dimensional array, where the first dimension has 3 as a shape 3, and the second dimension as a shape 2, right? So which means we have 3 rows and 2 columns, right? So the first parameter is number of rows, and second is number of columns. Okay, but it is not necessary that you should have only 2 dimensions. You can have as many dimensions as you want, depending on the number of elements that you have, right? So for simplicity, I'm just showcasing using a 2-dimensional array, but you can expand this into multiple dimensions. And another thing that you have to notice is that the reshape function will not affect your original array, right? So it will always return a copy. So what is happening here? So when I call y dot reshape, so it gave me this two-dimensional array, right? But it did not change the y that we created earlier, because y was a single dimensional array. So after calling this reshape, if we again look at what y contains, you can see that it has not changed. It is still it is still existing as a single dimensional array, right? So you have to remember that reshape function will be returning a copy, and it will not be changing your original variable. So if you want to change the change to persist, you can say y is equal to y dot reshape. You can assign it back to the same variable if you want it to, if you want the change to be permanently saved. So once I do that, if I look at y, so then y has changed, right? So I lost this single dimensional array because I do not have a reference to it anymore, because I reshaped it and then saved it back in the original variable. Okay, any questions so far? Yeah, so Shubham has asked a question: when we are creating an array, will the output be one-dimensional by default? So it will be one-dimensional by default if you gave a single list of values. So what do I mean by that is, if you say np.array, and then if I pass a list like 1 2 3, so this will give you one-dimensional array. But you can also directly give in multiple dimensions. For example, if I give a nested list, for example a list, okay, which contains 1 2 3, right, as a first element, and then I have another list 4 5 6. So in this case, you are passing in a nested list, right? So this nested list is two-dimensional, because so this outer list is your first dimension, right? Specifying your first dimension, and these inner list are telling you the second dimension. So in this case, you are getting a two-dimensional list as the output, right? So it is not always one-dimensional by default. It depends on the input that you are giving. If the input that you gave when you are creating the array is one-dimensional, then the output will also be one-dimensional. But if you are giving a multi-dimensional input, the output will also be in the same shape that you gave. But you can reshape it after you have imported, after you have created the array. Okay, what is the difference between float 32 and float 64? So both are floating point numbers. It depends on, so float 64 is more precise than float 32. So what do we mean by that is, you can represent more number of decimal places using float 64 correctly than you can using float 32, right? So with float 32, there is a very limited number of decimals that you can represent accurately. But if you want more precision, if you want more decimal places to be represented correctly, then you have to go for float 64. But the downside is the float 64 will require more storage space compared to a float 32 number. Okay, Sarfraz, do you have a question? You can unmute yourself and ask. Okay, so moving ahead. So then we also looked at the use of range function, right? So it has three parameters: the start, stop, and the step size parameter, right? So if I create range 1, 10, 1, 10, 2, let me convert it to a list so that we can see the numbers that are generated. So it gives me 1, 3, 5, 7, and 9 as the output, right? Because we are starting from 1 and each time incrementing it by 2 until we have reached 10, right? So 1, then 3, 5, 7, 9. So the next element, if we increment it by 2, would be 11, which will be greater than or equal to 10. So we will stop it, right? So this we can do with range, the built-in function, right? No problems there. But the disadvantage or one limitation of the range function is we cannot work with floating point numbers, right? So for example, if I wanted to create the numbers between 1.5 and 3 in increments of zero point 0.5, then I cannot do it with the range function, right? Because it will only take integers as the input, right? It cannot generate floating point numbers as output, so you will get an error. So however, if you want to create something like that, right, so then you can use the arange function from the numpy library. So numpy can work with the floating point range as well. So if you do this with numpy, right, instead of range, all you have to do is convert it into numpy.arange, and here you will get the output that you want. So starting from 1.5, incrementing it by zero point 0.5 every time. So 1.5 plus 0.5 is 2, from 2 plus 0.5 to 0.5. Then 2.5 plus 0.5 will be 3, so which is equal to the stop parameter, so it will not include that. So it works in exactly the same way as the range function, except that it supports floating point numbers as well, right? So this is also a function that you should remember when you want the range but using floating point, then you can use the numpy.arange. Yeah, sir. Regarding the assessments, you should contact the NPTEL support team, so they will be able to help you. Okay, can you try unmuting now? Because Google Meet options is enabled to unmute. Can you try once again? Okay, so Shubham, it should work. Maybe you can log out and then try logging in again. Okay. So continuing, so there is also another difference you should know about the built-in arrays versus the numpy arrays, which is in how the mathematical or the arithmetic operators work, right? So for example, we had the inbuilt array that was created, which was stored in the variable ARR, right? So this is a inbuilt array, right? So array of integers 1, 2, 3, 4, 5. So what happens when we multiply it, use the asterisk operator, and then multiply it by 2. So it's going to, replicate or repeat this array 2 times, right? So that's because that's how the multiplication operator is defined for the built-in sequence types, right? So array is one of the built-in sequence types, right? So when you multiply it by 2, it's going to replicate this by 2 times, just like other sequence data types that we have seen, other mutable sequence data types that we have seen, right? So list also will be when you multiply it by 2, it will be replicated it will become two times that same list. But what happens when you multiply a numpy array by 2? So here what happens is, instead of replicating the same array, it will do element wise multiplication, right? So because numpy array contain the numbers 1 2 3 4 5, right? So when you multiply it by 2, what it will do is multiply each element by 2, right? So that's how the multiplication operator is defined for a numpy array, right? So this is a difference that you should remember, right? So all the arithmetic operators will work element wise in a numpy array, right? So when you multiply it by 2, everything will be multiplied by 2. So on the addition operator, that is not defined for the inbuilt sequences, right? So you cannot add 1 to an array, built-in array, but you can add numbers to numpy array. So similar to how the multiplication work, so the addition also will be working element wise, right? So because it had 1 2 3 4 5 earlier, so when we add 10, so 10 is added to each element, and the output will be 11 12 13 14 15. And so this is another major difference between the built-in sequence type array and the numpy array. Okay, now let us create a two-dimensional array, right? So it has 1 2 3 4 5 6 and 7 8 9, right? So I'm using nested list to create this. So the array that I create is called Z, and then if you look at Z, so it has this 2 dimensions. So the shape will give me the output as 3 comma 3, because we have 3 rows, right? And then we have 3 columns, right? So first row has 1 2 3, second row 4 5 6, third row 7 8 9. And now numpy arrays come with some built-in functions that are very useful. For example, if I want to know the sum of all the elements in the array, so I can use the sum function, right? So z dot sum will give me what is the sum of all the elements in this. So sum from 1 to 9 is 45, right? So the output is a numpy integer type 45. And we also can do sum of the elements along a particular dimension, right? So in this case, we have 2 dimensions. So I can say z dot sum and then pass an axis parameter which is equal to 0. So 0 means give me the column wise sum, right? So the 0th dimension is the columns, right? So it will give me the sum along each column, so which is 12 15 and 18, right? So which is another array 12 15 and 18. So if you see the sum along each column, so first we have 1 4 and 7, so the sum of that is 12. So 2 5 and 8 15, 3 6 and 9 18, right? So we got the column wise sum. And if we do the row, if you want the row wise sum, then you can say axis is equal to 1, which is the other axis, right? Because we only have 2 axes in this particular array. So one is 0, the other is 1. So this is going to give me the row wise sums. So the first row has 1 2 3, the sum is 6. The second row has 4 5 6, sum is 15, and the third row 7 8 9, the sum is 24. Right? So we can get row wise and column wise or the total sums using the sum function. So similarly, there are other statistical functions that are defined on the numpy array. For example, mean. So what is mean? Mean is nothing but the average, right? So the arithmetic average. So mean is total divided by or sum divided by total elements, right? So this is the arithmetic average. So if we do z dot mean, so it will give me the mean over all the elements, right? So we have the sum, we take the sum of all the elements, which we know is 45, and we have 9 elements, right? So that is the length of this array. So if we say 45 by 9, so that will be 5, right? That is the arithmetic average over the whole array. But again, I can do the same thing along each column or along each row by specifying the axis parameter. So the column wise means are 4, 5, and 6. So 1, 4, and 7. Sum is 12, and we have 3 elements. So 12 by 3 is 4, and so on. So such kind of statistical functions are already defined with the numpy array. So you can easily call those functions and then get this. So similarly, the median, standard deviation. So all those are available that you can do. Right, so I can get the sum of z and the mean of z like this. Okay, so that's all the basics of the numpy library that we have covered so far. So do you have any specific questions before we move on to pandas? Yeah, Rajeshri, you can unmute. If you have a question, please go ahead. You can use NumPy and Spider as well. So the IDE that you use doesn't matter. So as long as you have NumPy installed, you will be able to use it.
NumPy is only limited for array operations, or it is applicable for different operations as well, like apart from array.
So it is for working with arrays. So NumPy will give you the ability to work with multi-dimensional arrays. So any operation that you can do on multi-dimensional arrays are supported. For example, you can represent matrices, right, using multi-dimensional array, and operations on matrices can be done, like matrix multiplication, dot products. So those kind of operations are possible.
Okay. Yeah.
Yeah. So there is the np dot dot, which we can use for getting the dot product and so on. If you want to do matrix multiplication, so there is a different operator, right? So because we saw when we used star, we got element wise multiplication. So if you want matrix multiplication, you have to use the at the rate operator. So this will do matrix multiplication. So if you have two NumPy arrays A and B, so A at the rate B would give you the matrix multiplication of A and B. Okay, so continuing further, what do we do for dot product? So for dot product, you should just use, you can do A dot B. So for example, I have the Z, right? So Z, uh, so I can use the inbuilt dot function. So I can give it another, yeah, I can use it this way, but the size should be compatible to do this operation, right? So because Z and X don't have a compatible dimension for dot product multiplication, so it's not working here, but this is the way you will call it. So when you have compatible dimensions for the dot product multiplication, you can call Z dot dot of X, right? So it will give you the dot product between Z and X. So there is also another way you can do it. You can call numpy dot dot, right, and you can give X and Z, right? So same thing. So you can use the dot inbuilt function for that particular array, or you can get the dot product function from NumPy and then pass in the arrays explicitly like this. So these are two ways in which you can do it. Can the range function be used in the following manner? Range of 10 comma 2. No, you can't do range of 10 comma 2, because what does this mean? So when you say range of 10 comma 2, you are saying start from 10, right, and then end before 2, incrementing by 1 each time, right? So if you have to say this in English, this is what it means, right? So when we say range of 10 comma 2, that's what it will mean, because we are saying specifying only two parameters, right, start and end, and this is giving you an empty list because it is not possible, right? So start, because 10 is greater than 2, right? So we cannot increment by 1 each time, right? And we cannot reach 2. So this is not possible to happen, right? Because the start is greater than 2, and our increment step size is positive. So this is giving you an empty list. So this is not possible, but you can do it in a reverse way. To give a negative step size, for example, -1. So then we can start from 10 and then go towards 10 by decrementing by -1 each time. So this will give you this particular output 10, 9, 8, because we are subtracting 1 from 10 by -1 each time to the previous element, right? So 10, then 9, then -1 gives you 8, 7, and so on. So we will not include 2, right? So that same rule will still apply. We will stop at 3. So this is possible, but when we do not give anything, so by default this is taken to be 1, and that will give you an empty list because it is not possible to go from 10 to 2 incrementing by 1. Okay, my teacher always asked to do by using for or if or while loops. How to do using these loops? Um, I don't know what you want to do using the for, while, or if. Can I give some more detail what you're trying to achieve using the loops? Okay, so cross product you want to do using the for loop while loop, right? So you can do it. So to understand, how the cross product works, it would be better, to write it into a for loop or while loop. But from an efficiency standpoint, so using the built-in functions would be much better because this will give you the calculations will be much more efficient when you're using the built-in functions instead of writing the loop yourselves, right? And also the chances of reducing the mistakes would be far less. So we can see an example later on. So how to do that using the for loops. But we have not reached that part yet, so we will skip it for now. But we can see it later if you want to implement it using the for loop or while loop. We can do that. Okay, any other questions? Okay, so moving ahead, so we'll now switch into pandas. Okay, so with pandas, so what we first begin with is how to read the data that we have, in external files using the pandas data frame. Okay, so again, we'll be looking at three different data types, data formats. One is the Excel worksheets, right? So this I think everyone is familiar with, right? So you have data organized in rows and formats, right? Each value is contained in a single cell. So when you want to read a particular, worksheet, workbook, so you can simply pass the name of or the path to that particular worksheet to the pd.readexcel. Again, remember that we imported the pandas library under the alias pd. So instead of calling pandas, you can just use pd when you want to, access some function within that library, right? So we are calling the pd dot read excel function, and we pass the path to where this file is saved, right? And in my particular case, so the file is saved in the same folder where this particular notebook is, right? So week 3 is the notebook that I'm working with, and this iris data sample.xlsx is in the same folder. So all I'm doing is just giving the name of that file, right? So it is in the current directory, which is represented by the dot. Suppose if it is in some other location, you give the full path to that location. For example, if it is in some other place, say C uh, users, user, say documents. So if it was somewhere else, so you give the absolute path to that particular file. So then you can read it even from other folders as well, right? But in my case, I can just do this because it is in the same folder. And if I do this, so it reads that particular file, and then it gives me a quick snapshot of what the data is there within that particular Excel file. Okay, so we have the different columns that is from that particular file, and then we have all the different rows, and by default it is showing me some rows from the top and some rows from the bottom, and it also tells me in how many values are there in total. So there are 150 rows and there are 6 columns. and you get one particular column here called unnamed zero, because within this particular Excel worksheet, so the first column did not have any name. So by default, Pandas has given a name for that called unnamed and zero, and the rest of the columns had a name defined. So it is using the name that was defined for it. And also for each row, you will have a separate set of labels to identify that particular row, and these will be starting from 0 all the way up to the last row number -1, right? So since we have 150 rows, so we are having the labels running from 0 to 149. So this is generated by default if you don't specify anything. And one more thing that you should need is the OpenPyXL library, so which is a dependency if you want to use the read Excel function, right? So even though if you have installed Pandas, if you want to read Excel files, you have to also install this additional library called OpenPyXL, so that you will be able to work with the Excel files. Okay, did someone have a question? Okay. So this is the basic thing that you need to read, a data file. So you just use the corresponding function, depending on the data format. So for Excel files, it is read Excel, and then you pass the path, file path to that particular function, right? So this is for Excel files. If you want to read text files, so there is a particular function called the read table, right? So similar to how read Excel works, again you can specify the path to that particular file, right? And there is an argument called separator. Let's first see what happens if we don't specify that argument. Right, so it is going to read this, but what is happening here is it is giving me 150 rows, but it is also not giving the 6 columns that we saw earlier, but only a single column. And if we see, all the single column has a very long text name. And also if you look at the values inside, so it looks like all the different values are put together. So what is happening here is, if you look into the text file, so we see that each value is separated by a white space, right? So within a particular row, so each column is separated by a white space, right? So and then each value is enclosed within using double quotes. So by default, what the read table function assumes is these columns are separated by tab spaces instead of a space, white space, single white space. It assumes that we have used the tab space to separate the rows. So that's the assumption that the read table function makes, but that is not true for this data. So we have to explicitly say what is the separator that is used. So the separator is a single white space. So we have to explicitly say that. So if we do that, then we get the same output, right? So because the data are separated by white space, so now it reads it correctly and then gives us 150 rows and 6 columns, right? So you have to remember about this separator, and if it is different from the default, which is tab space, you have to specify that. And there is another function called read CSV. So even though it says read CSV, it can also read text files, right? So by changing the separator. Right? So again, by default, the read CSV function uses comma as the separator. But since the text file that we want to read has white space, we can change the default separator by specifying the separate SAP argument. And this will also give me the same output as earlier, the read table, right? So you can use whatever is convenient. So there is no difference. You will get the same output, right? So the data that you load does not change. Okay, so the Excel file, you want to look at the Excel file. Let me open it. Give me 1 second. So this is the XLSX file, the Excel worksheet. So the data that it contains is this. So it has 6 columns, right? So columns B to F have a name defined, right? Sepal length, centimeter, and so on. but the first column A did not have a name, it was a blank cell. So that's why pandas has given a name by default as unnamed 0 for this. Okay, so did you get it? Yeah, so these sample data files are already available in the in the SWAYAM portal, so you can download it from there. Yeah, table versus CSV. So the basic difference is in the separator. So table, read table will assume that you are using a tab separated file. CSV assumes you are working with a comma separated file. So you should be able to use the CSV function itself for reading both by changing the separator. Okay, so moving ahead. So one more thing with respect to the Excel function, I forgot to mention is, different from your text files and CSV files, in Excel, you can have multiple worksheets, right? So like sheet 1, sheet 2, and sheet 3. So what read Excel does is by default, it will read the first sheet that is there within your workbook, right? So for example, if you had 3 sheets in your workbook, say sheet 1, sheet 2, and sheet 3, right? So 3 different Excel worksheets within the same file. So by default, this will read the sheet 1. But if you want to say read sheet 2 instead of sheet 1, so how can you do that is, there is a argument called sheet name, right? So you can use so two ways in which you can give input to this. One is in terms of numbers, right? So 0, 0, 1, or 2, right? So this is the order in which the sheets are stored within the Excel workbook. So in this case, 0 would mean we want to read sheet 1. And if I give 2, it means I want to read sheet 3, right? So like that, we can give the integers, which will represent the order in which the sheet name is there. Or we can directly give the name of the sheet that we want to read. Directly, I can say read sheet 2, right? So in this case, it will read the sheet which has the name as sheet 2, right? So this is also possible when you want to read a sheet that is not the first sheet within that file. So if you don't specify anything, it will default to reading whatever is the first sheet within the Excel workbook. Yeah, there is no limit on the size of the file using the read Excel function. The limitation may be coming from your computer, the amount of RAM that you have available in your system. So may limit the size of what you can read. But if you have enough RAM to read the whole file into memory, so then you can read it using the read Excel function. So the limitation is from the storage that you have, the RAM amount, the RAM memory that you have. Okay. Yeah, so with that, we'll move ahead and now we'll work with some data. So here I'm switching it to read this toyota.csv. Again, this data set is also shared with you in the portal. So this is a CSV file. So I'm reading it using the read CSV function. So I don't have to change the separator here, right? So because it's already comma separated, and so there is no issue there. So if I read this, so what we can quickly see is, there are 1436 observations and there are 11 columns. And so we have this first column unnamed 0, but basically what it is, if you closely look at it, it's exactly the same as, the index, the label column, right? So 0, 0, 1, 1, 2, 2. So it's exactly the same as that. So we don't want this to be a separate column in our data. So we want to set this to be the index itself. Okay, so instead of having it as a column, so you want to set this first, the column that didn't have any name, to be the index of our data frame. So how do we do that is, so we can say when we are reading the file, so we can specify index column is equal to 0. So again, similar to the sheet name, so this index column, if you give the number, it will take the order in which the columns are present. So 0 means it is the first column, right? So it will take this particular column and set it as the index instead of having it as a separate column. So if we read that and then look at the data, so now there is no unnamed zero, right? So instead of that, so that whatever values were there in that particular column is now set as the index here. So in this way you can get rid of that unnamed zero because it had exactly the same values as the index. Yeah, so the case should be matching. So because when we are using string, so it will try to match it exactly, because you can have different sheets uh, with capital and small cases. So you have to differentiate it by using the correct case. Okay. So this is one way. So the other way is if you did not care about whatever was the unnamed zero, if you wanted to remove it, right? So and have the default index. So you can do that also by drop. You can say the data frame to drop that particular column. So here what I'm doing is I'm reading that particular data frame. So I'm not specifying anything. So that unnamed zero is still there. But what I can do is I can ask it to just drop this particular column instead of setting that to be the index, because I already got a default index, right? So that works for me and I don't want this unnamed zero to be present. So I can drop it. So to drop any particular column from your data frame after reading it, you can do it in this way. So you can call the drop function on the data frame. So cars.drop, and then you can pass a list of column names that you want to be dropped to the columns parameter. Right, so I want only the unnamed zero to be dropped. So I create a list that contains only that single value as a string, and then I pass it to columns parameter. So after I do this, if you look at it, so when I read this data frame, I had unnamed zero, but after calling the drop and then making sure that change is reflected by setting it again into cars, I can see that that particular column is dropped. Right? So again, you have to remember that this drop will give you a copy of your original data frame, right? So to make sure that the changes are reflected in the original variable, you have to reassign it back into that variable. Okay, so this is how you can deal with the that unnamed unnecessary columns, or setting a particular column to be your label or row index. Okay, so then if you want have a quick summary of what your data frame contains, you can use the info function. So your data frame name and then dot info, if you call that, so you will get an output like this. So this will tell you how many values are there. So you have 1046 1436 rows, so which have index ranging from 0 to 1435, and we have 10 different columns, column number 0 to 9. So the name of the columns are given, and then number of non-null values, right? So what is a null value? A null value is something that is a value which is missing in your data frame, right? Or something that is not a valid value. Okay, so we had 1436 entries, right? 1436 rows. So if everything is perfect, we should have 1436 non-null values in all the columns. But what we see here is some of the columns, like fuel type, are having less than 1436, right? So fuel type is only 1336, which means 100 observations do not have a valid value for the fuel type variable. So that is the second piece of information that we get. And third is what is the type of data. So as I said earlier, so in a data frame, each column can contain only one type of data, right? So the price column is containing integer data. The age column contains floating point data. An object is used to represent string type data, right? So if you have strings, instead of string, it will pandas will use the data type called object. Right, so we have three different data types that are used in this particular data frame. So different columns can have different data types, but one particular column can have only one data type. So, and also we get a summary of what are the different data types. So we have two columns which have float 64 type, four columns in 64 type, and four columns of the object type, which means it is stored as strings. The values in that particular column is stored as strings in the data frame. And you can also see how much memory that this particular data frame is using. So this way you can get a quick snapshot of what this data frame has, in terms of memory, with the data type and the number of entries that are present in it. Okay, there are a few questions. when the file is read, how does Python assign data type to each column? Again, similar to how NumPy tried to guess what was the type of data, right? So when we did not specify it explicitly, Pandas also does the same. When it reads, it tries to go through each row in your data, and then it tries to assign a data type that is suitable, that can be used for all the values in it. For example, the price column had only integer numbers in that particular file, so it used the integer data type. And you have age floating point because it may have some floating point numbers, so it has chosen floating point to be best suitable. So, but we see here kilometer has an object data type. So even though we expect it to be an integer or a floating point number, because kilometer is say distance, right? So it's a numeric value, but it is using the object data type because there may be some mixed types, right? So for example, there may be some numbers and there may be some rows where there are characters present. So in that case, you cannot use integer, right, to represent a character or some special characters. So what Pandas has done is it has converted everything to be a string, because you can represent integers and floating point numbers are also as strings. So it has selected the best type of data, the best data type that can be used for all the values in that particular column. So that's how Pandas will assign the data type to each column. But we can change it later on. So we will see that further how to do that. Can the can the change column name using Python? Yeah, you can change the name of the column. So we can do that. That is possible. When to use square brackets or parenthesis? It is very confusing and hard to remember. So parenthesis we generally use, to call functions. So when you are using it in expressions, right? So it is used to specify the priority or precedence. For example, when you want to do say multiplication, 5 into 2 plus 3, right? So the output is 13 because the precedence is multiplication has a higher precedence than addition, right? So first the multiplication was carried out and then the addition was done. But if you want to change the precedence, so first it will do the addition now and then it will do the multiplication. So this is one use of using the parenthesis when you're using it in expressions to specify the precedence. So other uses when you're calling functions. So when you're calling functions, so you'll use the parenthesis to execute the function. So when you have a function which has a name called range, right? So, but when we want to execute it, we use the parenthesis after it. So this will execute that particular function, and then you can pass the values as arguments to it. So the square brackets, again, there are multiple use cases. So by default, when you don't have anything else, the square bracket would represent a list data type, right? So when we say one list, 1, 2, so it will give you a list. But when you are using it with some object, say so when we had the array, right, so created earlier. So with that sequence data types, when you use the square brackets, so you use it as an index operator. So you use it to select a particular element from a collection or a sequence, right? So here if I say array of 2, it will give me the third element, right? So 0, 1 and 2. So the output should be 3. So it will give me 3. So that's the basic difference. So parenthesis is for function calls and setting precedence in expressions, and the square brackets by default, if you don't use it with any other objects, it is for creating lists. But if you use it with some sequence data type, it is for indexing or slicing. Okay, category versus object data type. Yeah, object is basically for strings. Category is for storing when you have any very few unique values in a particular variable. So you can use the category data type for compact representation of it. So again, we will see how to do that. We will see an example of it. So category is for storing variables which have very few unique values in a very compact fashion. Yeah, why kilometer data type is object? Again, we will see why that is, because it will have some integers as well as strings, and because we have to use a single data type, So a string is used to represent both the integers as well as the other strings in it. That's why kilometer has object data type. Pandas object is considered as a string data type. Yes, in pandas object means it's a string data. So the Python automatically decides the data type for each column, or we can specify some specific data type. Yeah, you can also specify the data type for a particular column beforehand if you know. For example, say here age is float 64, but if you wanted it to be integer, or if you wanted price to be a floating point number instead of integer, you can also specify that when reading the data frame itself. So here, when reading it, again there is a d type parameter that you can specify. So you can give a dictionary, so where the key for the dictionary would be the name of the column, and the value would be the data type that you want it to be. So here I'm saying set the price, the data type of the price column to be float. So when you're reading it, so if you can see there is a subtle change. So earlier price was integers, right? Now because I gave float, you can see that there is a dot zero added to it, right, to indicate that these are floating point numbers. And you can see that when you call info now, so instead of int 64, it is now float 64. So this way, when you are reading in the data frame itself, if you know beforehand what is the type of data that it should be, so you can specify that. Or there is also a way to specify it after you have read it, so we will see that later. Yeah, again those, yeah, these the data types that are not making sense, so we will make it clear as we go forward. Do we have to eliminate object data type? Does not, you do not need to eliminate object data type, but if you have very few unique values like category data types, it's more efficient when if you have it as categories instead of representing those as strings. So in those cases it will be better if you convert them into the appropriate data type. It's not necessary that you have to eliminate all the object data types. Okay, moving forward. So if you want to select a particular column, right? So we have read the data frame. So if you see, so we are always getting this two-dimensional data, right? All the rows, all the columns. But if you want to select only a particular column from your data frame, say I want to only the kilometer column to be, I want to work with. So in that case, we can use the indexing operator, right? So using the square brackets and then specify the name of the column, using string. So in this case, what I get is another type of data. So this is called as, when you select a particular column, so what you get is a pandas series, right? So the two-dimensional data was pandas data frame, but if you select a particular column, so that what you get back is called as a pandas series, right? It's a single column. Right. So again, the question why it was represented using object, we can clearly see it here. So in the last few rows, we have some rows where we have question mark as the value, right? So most of the rows have integers, but some rows have some other characters, right? So because there is a mix of integers and characters, so pandas has used the object data type to represent all of them, right? So because we have to have a single data type, and we can't use represent question mark using an integer, right? So there we have used an object data type. So that is the answer to that. So this, you'll select a single column. Yeah, the commands will be the same. Whatever I'm using here, the same will work in Spider as well. So the command will not change depending on the IDE. So it depends only on the library that you're using. Okay. So now if I wanted to only extract unique values that are there in a particular column, so I can call the built-in the unique function within that object, right? So I call the cars km, so which will give me a series, and then the series has a method defined called unique. So if I call that unique function, it will give me all the unique values that are there within that particular column. So if I execute it alone, so you are going to get a sequence, an array, so which is going to contain only unique elements that are there, right? Again, it's not in any particular order, right? So if I want to sort it, I can use the numpy sort function. So I can pass this particular array that I have got as an input to the numpy sort function, and this will give me a sorted array. So when we sort it, what we are seeing is we have different, everything is represented as string, right? So that's the first observation. And then we see that there are some, invalid entries represented in terms of question marks. So this is the reason, as we saw earlier. So similarly, if we look at the other columns, which also had object data types that it was not supposed to be. So doors was one of the variables. So cars of doors will give me the doors column. And then the unique values, if I see again, so there are some integers represented as strings 3, 4, 5, 2, but there are also some text itself. Instead of number 3, there is the string 3, then string 4, and string 5. Again, because of this mixture of integers and also strings text, the pandas has assigned the data type to be object, right? So this is also one of the issue. And then if you look at the fuel type column, also had this issue as object. If you look at it, there are three unique values that are valid, like diesel, petrol, and CNG, but there is also nan. So what happens, why is this nan coming, is because if you have blank values in any of the cells, so pandas will convert those blank values into nan. So nan stands for not a number. So nan means not a number. So this is used to represent blank cells in your data frame. So again, because a mixture of string and nans are there, it is using the object data type. By default, nan would have the data type of float, right? So nans are floating point representations. So again, because of this mixture of two data types, you are having the object data type here. And again, if you look at horsepower, again it has some strings, string representing some values that are missing. So because of that, it is also having the object data type. So we have to now see how to correct these. So the first one is we are having multiple representations of values that are missing, right? So in some columns which were blank, we are using nan to represent it. In some other columns, we have represented using question marks, 4 question marks, 2 question marks. So we have to first unify all these, right? So to do that, what we will do is, so when we are reading the data frame itself, so we can specify what are the different values that all should be considered as not a numbers, right? So in our case, the 2 question mark and the 4 question marks are also indicating the missing values, right? So we are going to specify this list when we are reading the data frame itself to represent those as well as not a numbers. So I'm reading the data frame. So again, looking into the data type. So again, this does not affect some columns like fuel type, which had blank cells which are already null, but it reduced the number of non-null values in some of the other columns. For example, in HP, right? So we have now 1430, right? So because it has increased the number of non-null values because it had some question marks earlier, right? So there were these 4 question marks. So these are, instead of considering it to be a valid value, so these are converted into null values. So the number of null values in the HP column has increased. All right. So this is the first one that we have to do. We have to have a unique representation of all the null values. So next we are going to see how to convert these data types from one type to the other. So first, fuel type. So because we want fuel type to be a category, right? So why? Because when we looked at the unique values, we saw there were only 3 unique values: diesel, petrol, and CNG, right? So these are 3 different categories that we have. So instead of storing a string for each cell, so we can convert it into a category, and the advantage of that we will quickly see. So when you look at the output, it's not much different from what we had earlier, right? So again, it looks like we are having strings, right? And then also the missing values are there represented as not a number, but it looks very similar to what it was there earlier. But the difference is instead of strings, we are representing these using categories, and these are the 3 categories that Pandas has detected, right? So CNG, diesel, and petrol. So the advantage that we get when we are working with categories is, one, in terms of the space savings. So here now we see, once we have converted fuel type into a category, So the memory usage is now 113.7 kilobytes. So compare this to earlier, it was 123.4 kilobytes, right? So there is a space saving that we are getting. So why is the space saving occurring? So what it does, Pandas does is, because there are only three categories, so it will assign some numbers to these three categories. For example, let us say 0 means CNG, 1 means diesel, and 2 means petrol. And wherever diesel is there, so internally in the memory, Pandas will, instead of putting diesel, instead of storing a string diesel, it will use that integer 0. And wherever petrol is there, it will use the integer 2, and wherever diesel CNG is there, it will use the integer 0. So it will represent it, representing it using the smaller width integers. For example, int 8 would be sufficient because we have only three categories, right? So because of that, instead of storing strings which will require higher storage, it will use a compact representation. So because of that, you are getting very efficient memory usage. So that is one of the advantage that you get when you're converting it into the category data type. So you do this where it is more appropriate. Okay, let me check if there are any questions. Sahaya, I don't understand your question. The data type is object. So what do you mean by that? Okay, so moving ahead. So let's look at car doors. So here we want to again fix this particular issue where we have some strings, but what we want ideally is to be represented these using numbers, right? Integers. So what we can do is we want this text to be replaced, right? So we want wherever there is 3, we want it to be the number 3, and wherever there is 4, we want it to be number 4, and wherever there is 5, we want to represent it by the number 5. So this is the case where we are trying to replace a particular set of values with another set of values. So here we can make use of the replace function. So just like how we use the unique, we can also use the replace function. So the replace function will take a mapping, right? So the mapping will tell what is the old value and what is the new value. Okay. So here the old value or the existing value is the string 3, and the new value that it should be replaced with is the integer 3. Okay. So if we do that, so let's see what cars door have now. Okay, so it has some numbers already and some strings, right? So the first one is 3. So when we do this replacement, so what we see is, so instead of the string 3, it has been replaced with the number 3, right? So similarly, the other rows where the other values were there, those would also be replaced. And again, we have to remember that this is not changing the original data frame. It is giving us a copy. So to make sure that those changes are saved, we have to replace it back into the same variable. Okay, so before that, one more thing that we have to do is, so when we did the replacement, still we see that it is having an object data type. So why is this occurring? Because even though wherever the texts were there, 3, 4, 5, we replaced it with integers. So when pandas read this data frame, so the rest of the columns were also converted into strings, right? So even the numbers were represented using strings. So that's why it is still having the object data type. So in this case, we are going to explicitly convert the data type into an integer. So we are going to chain two commands. So what we are saying is take the car doors column, do this replacement, right? So where we have told what old value should be replaced with what new value. After doing the replacement, convert the type of this whole column into an integer. Okay, so that's what we are doing here. So this is called chaining multiple functions. Okay, so we are doing it in order. So first take this variable, then call this function on that variable, then call this function on the output of that particular replacement. So if we do this, now we are seeing the output to be an integer instead of an object, because first we converted all the text into strings which string representations of the integers, and then we converted the data types from the string to an integer. So finally we get an integer column, right? So now what I'm doing is just doing that same thing, and then the output of that I'm replacing it in the same column. Okay, so with this we fix the doors data. So next Similarly, what I'm doing is I'm also converting the categories for met color and automatic. So met color is whether the car has a metallic color or not, right? So it should also be a categorical variable basically. So if you look at that, so met color, it's a category, but it is represented using floating point because we are using 0 or 1, right? So 0 means it is not having metallic color, 1 means it has metallic color. But again, we do not want, floating point data, to be used here because there are only two unique values and it's more suitable to represent this using a category data type. So I want met color to be converted into a category, and also the automatic column, so which means whether the transmission of the car is automatic or manual, right? So again, this is also represented using integers here, but it has only two unique values, 0 and 1. So 0 means it is not automatic and 1 means it is automatic. So again, it's better to be representing this using the category data type. So here what I'm doing is I'm doing this conversion on multiple columns, right? So again, you can, instead of selecting single column, so you can also use call multiple columns by passing a list of column names instead of a single column name. So here we use a string to extract a single column, but we can give a list of strings to get multiple columns. And the output of this would be, instead of a pandas series, this will again be a data frame because we have selecting multiple columns. So this is again a data frame, but with a subset of the original number of columns, only the met color and automatic. So here I am converting these two columns into category and again replacing that in the original data frame. So now if we go back and look at the summary, right? So we have changed the fuel type data from object to category, the met color from object to category, and also automatic from object to category, right? So that's all I want to do. So doors also, if you want, you can keep it as category, but I would prefer it to be an integer, right? So even though it has few number of values, I prefer it to be a numeric variable. So I'm keeping it as integer. So we have fixed the data type issues. Okay, any questions so far? Okay, so category data type. So category is just an efficient way of representing the values in your particular variable, right? So for example, here in the met color we have only two values, right? So one is 1, the other value is 0, right? So then there are only two unique values. So these are representing two groups of observations. One group of observation where the metallic color, one group of cars where the metallic color is there, which have metallic color, the other group of cars which do not have metallic colors, right? So the categories are nothing but different groups of your observations. And when you have very few number of categories, that is the case usually. So in that case, you can convert the type of the data. Instead of storing this as integers, floating point numbers, or strings, if you convert it into a category, what you will get is an efficient way of representing them in the memory. So you'll get some space savings. So what happened here? So initially we started with 123 I think kilobytes, right? So when we didn't do any changes and everything was represented as a string, so we had 123 kilobytes of memory use. And after we had changed some of these columns into categories as appropriate, so finally we are using only 94 kilobytes, right? So while in this case the savings may not seem huge because we are not dealing with a very large data frame. Yeah, we have only less than 1500 observations, but we are only, when you're working with big data, right? So say millions of observations, so the space savings that you will get will be very huge, right? So you can save few gigabytes of memory, so when you are using the efficient representations. So that's the major difference that you get. And also later on, some machine learning algorithms that you will see will have some native support for categorical variables, right? So depending, for example, the XGBoost, the gradient boosting trees will have support for categorical variables natively. So depending on whether it's a category or not, so it will be able to choose appropriate techniques to deal with it. So when you specify the D type as category here, so you do not have to explicitly set that when you are working with those libraries. Okay, so that is one of the advantage that you get. Okay, so other question is last session video. So the previous session videos are available on YouTube. So the link to those videos are available in the portal. So you can look into the portal. So there will be a live session tab on the left. So if you click that, you'll get a Google sheet. So within the Google sheet, the links for all the sessions will be available. Okay, now if we look at the shape, so similar to the NumPy arrays, we can also access the shape of this data frame. Right? So instead of if you just needed the shape and don't want the summary, you can just call the shape attribute, and that will tell you how many what is the shape of this data frame. So there are 1436 rows and 10 columns. And another useful function is the describe function. So this is for getting statistical summary, right? So what summary that we have seen so far is an overview of how many rows, how many columns, right? But if you want the numerical, statistical summary, you can use the describe function. So this will give you for all the by default for all the numerical columns, so that is integers and floating point numbers, it will give you what we generally call as a 5-number summary, but here we have more than 5 numbers for each. But general the 5-number summary is, so what is the minimum, what is the maximum, and the interquartile range. So that is the 25th percentile, 50th percentile, and the 75th percentile. In addition to that, this also gives you the mean, standard deviation, and the number of non-null values in those numerical columns. For example, if we take the price column, so there are 1436 non-null observations. So the mean price, that is the average price of all the cars, that is all the non-null observations, is 10,730. The standard deviation is 3,626, and so on. So we get the minimum value. The maximum price is 32,500. And then we get 25th percentile. This is not percentage. This is 25th percentile, 50th percentile, and 75th percentile. So what is percentile? So this percentile tells you, so if you sort your data, and then you take this particular value 8,450, then 25% of your observations will be below 8,450. The values for 25% of your observations will be less than 8,450. And 50% means 50% of your observations has a price less than 9,900, right? So there is another name for 50 percentile. So that is called the median, right? So it is the middle value, right? So it means that 50% of your observation has less than 9,900 and 50% has more than 9,900. Similarly, you get the 75th percentile. So this kind of statistical summary you can get for all the numerical columns in your data using the describe function. So this is so by default it selects the numerical columns, but you can also get this summaries for the categorical columns as well. So here to do that we have to select the categorical columns first. So how do we do that? So we can use the select details to select or a particular type of data types. For example, if I call cars.select dtypes and I say include is equal to category, then it will return only those columns from the data frame which has the data type of category. So because we have only 3 categorical data types, which is fuel type, metallic color, and automatic, I'm getting a subset of the data frame which is containing only those 3 columns. So this is a quick way of selecting it. Say, but if I wanted only the integer columns, I can say include is equal to select details include is equal to int, then I get only the integer data type columns. Similarly, I can get the floating point data types as well. Okay, so for this example, I want to work with the categorical columns. So I'm calling the I'm including the category, and I can now call the describe function on these particular columns. So if you see this, the output is slightly different, right? So earlier we got the statistical summary in terms of standard deviation, means, and percentiles. But that those numbers don't make sense when you're working with categories, right? So because the categories are are representing groups of observations, and the number itself in the categories generally do not make sense. So we are looking at different summaries here. So one is again the count of the number of non-null observations. right? So again, that is different because metallic color has more non-null observations, more null observations, right? So it has only 1286 which are non-null. So that is the first one you are getting, and then you are getting the unique. Unique means how many unique values are there. So fuel type, we had three unique types: diesel, CNG, petrol. So it is three. In metallic and automatic, we had only two categories, right? So either one or zero. Metallic color is true or false. Similarly, it is automatic or manual. Only two categories. And then you get which is the category that has the highest number of observations, right? So top means, so petrol means most of the cars in our data type, in our data frame, has petrol as the fuel type. And again, most of the observations have metallic color, and most of the observations have a manual transmission, right? So that's what the top category means. So which category has the highest number of observation, and then frequency tells how many of those observations are belonging to that category, top category. So out of 1336, 1177 observations have petrol fuel type. So out of 1286, 868 cars have metallic color, and so on, right? So that's the summary that the describe function gives for the categorical columns, right? So this way you can get it. Yeah, so this is the final data frame that we are having. So then similar to how we work, use the indexing in the lists and other sequence types, right? So when you want to extract a particular subset, so we can do the same thing using the data frame as well, right? So because we have two dimensions in the data frame, so we'll have when we are doing the indexing, we can give two sets of indices, one for the rows that we want to select, the other is for the columns that we want to select. And for this, we can do again using multiple ways. So one way is using the dot loc. So loc is for the location, right? So if I want to select, say, the column, the row that has a label 1432 and the column which has a label fuel type, so then I would use this way. So where I say cars dot location dot loc, and then first we have to tell the row index, and then we have to give the column index. Okay, so the output of this is petrol because under the fuel type column in the row that has the label 1432, we have the value petrol, right? So that's what it is returning. So in this way we can select a particular cell from our data frame. So similarly, I can get it for another variable as well. So the second the row with the label 2 from the kilometer column. So the row with the label 2 from kilometer column. So that is 41,711. So that is the output that we are getting. Right. So again, we need not select a particular cell. We can also select a subset of rows or columns. Right. So we can use the slicing operators that we have seen before. Right. So here I can I'm using the same function cars.loc, and instead of a single integer, I'm giving a slice here. So :5. So what does :5 means? So when we don't specify a number before the colon, it means by default it will take it to be the first observation, right? So it will default to 0 here. So it is like saying 0:5, which means take everything from 0 to 5, all the rows from 0 to 5, and then again I can select multiple columns. So instead of a single column name, I can give a list of column names, and this will give me a subset of those columns. So here we are seeing that HP and doors columns are given, and the observations with label indices from 0 to 5. So one difference that you will notice from, say, list indexing that we have used earlier is, so when we just generally do slicing, the stop index would not be included, right? So for example, we had the values list. So here if I say values :2, so what do I get? I only get the 0th index and the first index, right? The second index, which I have specified in the stop, is not returned, right? But here we see that the index 5 is also there. So that is one of the differences that you have to keep in mind when you are using the .loc, right? So both the start as well as the end will be included in the output. Okay, but there is another function similar to loc, that is called iloc, which means integer location. So instead of using the actual values of the labels, we are going to use the integer positions, right? So in this case, always the first one's integer index would be 0, and then it will go on incrementing by 1, right? So 0, 1, 2, 3. So in this case, the integer index is same as here. the labels that you're having here. But in some cases, you can have some other labels as well that we have not seen, but it is possible to have some other labels instead of these numbers. So in that case, the integer location would be different. And the other difference is instead of column names, now we have to use the integer positions of the columns as well. So if I say colon 2, it means that select the first and the second column with index 0 and column with index 1. So the price and age should be returned here. So the output of this, right? So price and the age columns are selected, the 0 and 1. And then when I'm giving 1 to 8, so in this case, the row from the row index 1 to 7 only will be included. So this will work in the same way as other sequence works. So this is different from the LOC, right? So this is ILOC. So here, as we are used to, the end index will not be included. So we have the values from 1 to 7, but not 8, right? So this difference you should know between LOC and ILOC. Yeah, is this pandas? Yeah, this is using pandas. So we all these operations that we are doing is on the pandas data frame that we have read earlier called cars. Okay, so that's all about the basics about using the pandas data frame. So how to read, convert data types, select particular rows, columns. Is there any question so far before we move into control statements? This video will be uploaded to YouTube. The link for the video will be in the Swayam portal. Any other questions? Okay, so moving on. So now we'll go into control statements where we'll look at if else statements and also loops using for and while. So when do we use if and else? So when you want to execute some statements depending on some conditions, right? So for example here the two statements that I'm interested in are the print statements. Okay, print, which prints the message greater or the message lesser, but I do not want both of these to be executed. So depending on, in some cases, I want this print function, this print call to be done. And in some other cases, I want this print call to be done. Okay. So what is that condition? I have two variables called 5 and 7. And the values that these variables store is also the integer 5 and integer 7. Right. And I want to print the value greater if the value in the variable 5 is greater than the value in the variable 7, right? And we know that this 5 is greater than 7, right? So we can expect that print greater to be printed. So if we run this cell, sorry, 5 is lesser than 7, right? So I'm sorry, so this condition is false, so greater will not be printed and lesser will be printed. Right, so like here again, based with depending on a particular condition, we are able to control which set of statements get executed. Again, it need not be just a single statement here. You can have multiple statement, right? So depending on this, I wanted to say add these two variables and print it. But in the other case, say I wanted to print the difference. Right, so we can have multiple statements, that can be conditionally executed. So in this case, because 5 is less than 7, the condition that we give here, is false. So this whole block of code is skipped by Python, and then the else block of code is executed. So first it will print lesser, and then next it will print the difference between 5 and 7, right? So that is -2. 5 minus 7 is -2. Right. So the syntax is you use the if keyword, then you give a space, and then you define the condition that you want to evaluate, right? And then you end it with a colon, right? And then you have to in the next line you have to give an indentation, right? So this indentation will be something that is larger than the number of spaces that is larger than what is there before if, right? So before if there is no no spaces, so you can just indent everything using one space, but you have to be consistent. right? So if I use one space, I have to use one space everywhere within that particular block. I can do this, right? But in general, people use 2 or 4 spaces, right? So you can follow that. So this is just a visual thing, right? So you use some indentation, and then you print and then you write your statements that should be executed when that condition becomes true. And then it's perfectly fine if you don't have an else block. So in this case, what happens? Nothing will be executed, within that if, because that condition is false. And after that if, we don't have anything else. So there is no output. But this else part is optional. If you want to do something when the condition is false, then you can define an else clause, right? So else, there is no condition here. So if this is false, directly whatever is within this else block will get executed. So again, you have to use the keyword else, and then you put a colon, and then again within the same indentation, you have to define the statement that you want to be executed. Okay, so this is how you define the you use if statements, if else blocks. So here I'm changing the condition. So now the condition is, instead of 5 greater than 7, I'm saying if 5 is less than or equal to 7, then print the statement. Otherwise, you have to print this statement. So in this case, what happens? Instead of the else block, we are executing the if block, right? Why? Because this condition now evaluates to true, right? So we are using the comparison operator less than equal to, and 5 less than equal to 7 is true. So therefore, this condition evaluates to true, and therefore the if block gets executed. So we are getting the output as less than or equal instead of greater, right? So depending on the condition, so you will be able to print one set, you will be able to execute one set of statements or the other set of statements using if else. But what if you wanted, more control, right? So more, if you want to execute, you want multiple pieces of statements depending on multiple conditions. So in that case, you can have multiple conditions to be checked sequentially using if, else if, and else, right? So here I'm creating another variable called num, which has the value 6, right? So the first condition that I'm checking is whether num is equal to 5. So equal to, if you remember, this is the equality comparison operator, right? So here we are not assigning the value in 5 to num. We are checking whether the values in the variable num and the value in the variable 5 are same, right? So if they are same, then I wanted to print num is 5. Okay, and if this condition is not true, then I want to check one more condition. So that condition is whether num is equal to the value 6. So if that condition is true, then I want this statement to be printed, num is 6. If that is also false, then without checking any other condition, I just want to print unknown num. So if I run this cell, so what I'm getting is num is 6. So why is this happening? Because the variable num is containing the integer 6, and the first condition is num equals 5. Num is containing the value 6, and 5 is containing the value 5, right? So 6 is not equal to 5. So therefore this condition becomes false. So we skip this block of code. So then we move on to the next condition. So where we are checking the num is equal to 6, and this becomes true. Therefore, this print statement is executed. And once the condition is true, whatever statements are there after that, so those are skipped, right? So the else block is totally skipped here, and therefore unknown num is not printed. And you can also expand this into more than 3, right? So you can have multiple things as well. So you can have, say, num is equal to 4, and so on, right? So you can have multiple elifs following the if, right? So you can have as many elifs you want. And again, in this case also, the else is not a mandatory, right? So again, if I suppose change this condition so that all the 3 conditions fail, so in this case, I will not get any output, right? So because all 3 conditions failed and I didn't have any else clause, so nothing is executed in this case. Okay, so is there any doubt regarding the if statements? Yeah, the exact difference between lock and ilock is integer location value. Is this right? Yes. Lock will use the label value, so which may be an integer or may not be an integer. But iloc will always, irrespective of what is the index that you are using, it will always use the integer position, starting from 0 for the first row to say n minus 1 for the last row. Cars data dot get d type counts is giving an error. Okay, so if you want the d type count, so you can do cars dot and just put d types. It will tell you what are the types for each of it, or the info will also give you that same summary. So it will tell you how many different data types are there and how many columns are falling in that particular category. So difference between nested if and elif. Okay, so nested if and elif. So nested if is if you have an if condition within another if condition, right? Say if 4 is greater than 5, maybe 4 is less than 5. If 3 is greater than 2, so this is an example of having a nested if, right? So here what happens is, so first you have an outer block of if else, okay, that is if 4 less than 5, and if that condition fails, you'll directly go to this else clause, okay. But what we are doing here is, once this condition becomes true, we want to make sure another condition is also true. So that is if 3 is greater than 2. So in that case, we are going to print 3 is greater than 2. So here we are having a nested if clause, right? So within one if clause, we are having another if clause. So that is nested. So within one if, you have another if. Else if is in the same level, right? So if one fails, you check for another condition. If 4 greater than 5, say something, if 3 less than 2, this is another thing. And then you have else. Okay, so this is the else if. So here what happens is, when this first condition fails, then you will go into the else if part, right? So whereas the difference here is, if the first condition is true, then only you will be checking for the second condition, right? So that is the difference here. This has to be true and this has to be true for this part to be executed. Whereas in the else if, the first condition has to be false and then the second condition has to be true for this set of statements to be executed. So that's the difference between the nested if and else if. Class.info and class.describe, are these two same functions same? No, they are not the same. So class info will give you a a summary in terms of how many what columns are there, how many numbers are valid in that particular column, and what is the data type, right? So this is the summary you get from info, whereas describe will give you a statistical summary. So that will give you the statistics of the mean, median, the percentiles, and so on, right? So this is what you get from describe. So for numerical columns, you'll get this kind of summary. For categorical variables, you'll get the frequency distribution summary. So info and describe, they are not same. They give different summaries. One is statistical, another one is a way of telling you about the number of observations and data types. Yeah, you can drop columns when you're using the describe function. You can use you can select a subset of column and then call describe on the subset. For example, If I wanted the summary of only the price and age, I can just select these two columns, right? Price and age, and then I can call describe. So this way you can get the summary for a subset of columns as well. Okay, so next let's move into loops. So the first loop that we saw is a for loop. So what is a for loop? So when you have a sequence of values and you want to iterate over those sequence of values and do something with those individual values, you use a for loop. For example, here we have numbers, which is a list containing three integers 1, 2, and 3. And if I want to do something with each of these integers, right, separately, then how I would do that is using a for loop. So the syntax is you say for, right, give a space, and then you use a variable name, right, and then you give use the keyword in, and then you give the sequence of values that you want to work with. In this case it is numbers, and then you finish it with a colon. And similar to if, we have to make one indentation, right? So in this case I'm using 4 spaces, and the thing that I want to do is I want to just print that particular value. So I'm just saying print type. So what happens in this case, the output you get is like this. So you'll get 1 printed, then 2 printed, then 3 printed. So what is happening is, so this particular set of statements that is there within this for loop, so will be executed n number of times, where n is the number of elements that you have in your sequence, right? So the sequence that you're specifying. So here you have 3 elements, so this print statement will be executed 3 times, and each time the this variable that you have in the for loop will be changed, right? So starting from the first element, each time the value will be changed into the next element. So the value of I will be 1 in the first iteration, then it will execute the print statement, then the value of I will change to 2, which is the second element in the numbers, then it will print 2, then the value of I will be changed to 3, and then it will print 3. So that's how the for loop will work. So it will go through the sequence one at the values in the sequence one at a time, and then change this variable value, and then whatever statements you have within this, those will be executed with that value of the variable. So instead of printing, so what I want to do here is, with those same sequence, I want to go through it again. So this time I want to print the square of the numbers that are there. So what will the output be? So it will be 1, 4, and 9. So why is this happening? So in the first iteration, so I will be equal to 1, which is the first number in the list. And then what I'm doing it, I'm squaring that number and then printing the output. Okay, so first square of 1 is 1. So then the value of I is changed to the second element in the sequence, which is 2, and then I'm printing the square of that. So 2 square is 4, and then the last number in the list is 3, so the square of 3 is 9. So that's how the for loop works. It's very simple. So you can just very simple syntax, you use a variable name to store the individual element from the sequence, and then you specify what the sequence is, and then you have to define the logic of what you want to do with each element in that particular sequence, right? So here we can also combine these for loops with your if statements that we saw earlier, right? So what here I want to do is, I want to go through all the numbers, and I want to only work with even numbers. Okay, so how do we check even numbers? I can divide the number by 2 and check whether the remainder is 0 or not, right? So if the remainder is 0, I'm using the modulo operator. When only that case I want to print the square. So what happens here? Here I'm getting the output as 4 instead of 149. So what is happening? So in the first iteration, the value of I is 1, which is the first number. Then this whole thing will be executed, but this particular statement is an if condition, right? So it has to check this condition, and only if that is true, then only this print will be executed. So first is 1, so 1 mod 2 is equal to 0 is not false, because the remainder will be 1, so it's an odd number, so this print is not executed, and I don't have an else clause, so nothing more is there. So the for loop will change the value of I to the next number, which is 2, right? So then 2 will pass this condition because it is even, and then the square of that got printed, and again there is nothing more to do. So the for loop will continue, and the value of I will change to 3, and 3 again is odd, so this condition will fail and the print is not executed for that. So the output is only 4. So this way you can work with a collection of numbers or any other values, right? So whatever be that, you can work with collection of items using the for loop, right? And when that so the the termination is defined, so when all the numbers are executed, so the for loop will finish. So that's how you can use the for loop. So you can do this in any other number of ways. So you can use combine with other functions that we have seen earlier. So we saw maybe in the first class the reversed function, right? So what does reverse do? Reversed is a built-in function. If you give it a sequence, it will give you a reversed sequence, right? So here we have numbers as a list 1 2 3. So if you pass reversed numbers to reversed, it will give you a new list in the reversed order. Let me just execute that. So you'll get reversed of numbers. It's a reversed iterator. So you have to convert this into a list, explicitly see it. Right? So I get a reversed list of 3 to 1. So therefore what happens here when I'm printing the I into 10, so instead of 10 20 30, what I'm getting is 30 20 and 10, because I'm iterating it in the reverse order. Right, so that's all there is to while loop. So this is the basic syntax that you need to remember to work with for loops. So another related way of looping over items is the while loop. So in while loop we have to instead of a sequence, we have to specify a condition, right? And the while loop, the statements within the while loop will continue to run as long as this condition that you have specified validates to true, right? So here what I'm doing is I'm creating a variable called num, which is set to 0 initially, and the condition that I am saying is execute all these statements until num is less than 5, right? So what happens, initially num is 0. So first time what it will do, it will check whether while num is less than 5, which will be true, 0 is less than 5. So the condition is true, it goes into this, it will print whatever is here. Then I'm changing the value of num, right? So it's the same variable, I'm changing it, I'm incrementing it by 1. So after doing this incrementation, so there is nothing else left. So it will again go back to evaluating this condition, and this time 1 is compared with 5 because num is now 1, right? So 1 is less than 5, the condition will still be true, and then it will go on executing this. So what happens is when you see the output, so first it prints working with num 0 because that was the initial value. Then we incremented num to 1, and then we again checked the condition. So it was true. So it printed working with num 1. So then again the num value is incremented to 2, which satisfied the condition, and it kept on going until num was 4, right? So when num was 4, it printed working with num 4, and then it was incremented to 5, in which case the condition evaluated to false, right? Because 5 is not less than 5, right? 5 is equal to 5. So this condition became false. Then it stopped going into the loop, and then it didn't execute it and came out, right? So that's how this while loop worked. So is there any question so far? Yeah, is it possible to print 1 2 3 horizontal format? Yeah, you can do that. So by default, what Python will do is when you call the print function, after printing whatever you have given inside, it will print a new line character. So that's why the next time you call print, it is in a new line. So but what you can do, there is a parameter called end. So if you say instead of a new line, I just want it to be, I don't want anything at the end, you can just specify an empty string, right? So just putting double quotes here. So don't put anything after I. So if I do that, so what happens is output will be 1 2 3, because first it printed 1, after that it didn't put any new line character or anything. The next time it continued from there, printed 2, then it printed 3. But if you say wanted comma, you can say comma as well. Then it will put, first time it will print 1 comma, next time it will print 2 comma, third time it will print 3 comma. So that also you could do. So you can customize this as you like. Okay. How can we know how many following statements will be inside the while loop? Yeah, so that is a good question. So here the number of iterations is not predefined, right? So it depends on how this condition changes every time the loop changes. So here it is deterministic, right? So because we know what is the starting value, it is 0, and every time we are incrementing it by 1, so it will go 5 times. So we know that, right? So but in some cases we may not know. If say the if we are going to say get an user input, and depending on the user input we are going to check this condition, so in that case we cannot say beforehand how many times the while loop will work, right? So it sometimes it is possible to say how many times this will occur, sometimes it is not possible to say, so depending on how you are checking the condition. Okay. So just one more example with the while loop. Say I have a list of fruits, say apple, orange, and banana. And in this case, I'm writing the condition in a different way. So to show that you need not always have some numbers, right? So you can have other ways of writing the condition. So here what I'm saying is while length of fruits. So what does length of fruits give you? So if I put it in a new cell, fruits. So length of fruits will tell you how many elements are there inside that, right? So it is an integer. The output of length of fruits is an integer. So what does it mean to give a condition as an integer? So the in Python, all your non-zero integers, right? So they will be evaluated to true, right? So if the output of length of fruits is non-zero, then this while loop will consider that to be true, and then it will execute whatever is there inside. And if the length of fruits is 0, so that is the condition when it will be false, and then it will stop doing this. So what I'm doing is, so first time is length of fruits is 4, so this condition is true, and it will go ahead and execute this, right? And it prints sold, and then what I'm printing is I'm taking the last element of the fruits out, right? So the pop function of the list will remove the last element, and it will give you that as the output. So the last element was banana, and then it said sold banana, and fruits left is whatever is left in the list, right? Now it became 3 elements, right? Instead of 4, apple, orange, and orange. So the next time this loop runs, length of fruits will be 3 instead of 4, because we only have 3 elements, and it will continue, and the last element now will be orange. So orange is removed, and it said sold orange, and the length became 2 now. It still continues, and it removed orange, and it in the end it removed apple. So once it removed apple, so we didn't have anything in our list, right? So list was empty, so the length of list is 0, and the condition became false because 0 is considered to be false in Python. So the condition is not true anymore, so that the loop stops. So this is also another way in which you can use the while loops. So different ways in which you can write your termination conditions. Okay, so next we'll quickly look at functions. So functions is for when you want to repeat, reuse a particular set of code, again and again. So then functions are an efficient way of doing that, right? So suppose here I want to add the value 1 to some variable, right? So I'm creating a function. So to create a function, we have to use the def keyword define, and then we have to give a name for that function, and then we use the parenthesis. Within that we can tell what are the inputs that this function will take in, right? So it can be it need not always take an input, it can be blank as well, but in this case we are going to receive some value that is stored in the variable val, and then we finish it with a colon. Again we have to indent it, and then give the what we will do within that function. And in the end, we can also return some value when this function is called using the keyword called return, right? So even if you don't return anything, Python by default will return the none type object. Okay, but here we want to specifically return something. So what we are doing is, once we get some value in this function is called, we are going to add 1 to that particular variable, and then return that new value. Okay, so that is the function we are defining. And to call this function, what we will do, just like any other built-in, right? So we use the range function. So how will we do? We give the name of the function, and we put parentheses, and we give the values, right? So similar to that, we can call our own functions as well. So the name of the function is add underscore one, and then it takes in one value. So I'm passing the value 5. So what it will do, it will take in 5, it will add 1, and then it will return that new value, so which is 6, right? So I'm getting 6. So I can call this function with any other value as well. So 1 2 3 4. If I pass it in, it will give me 1 2 3 5. So see, I didn't have to write this statement again, right? So I'm just reusing that by calling this function by with a different value. So that is the advantage of the functions. You can reuse pieces of code uh, you know uh, with the different values each time. Here I'm defining another function called square. So it will take in a value and then it will give me the square of that value as the output. So here I'm calling square with the input 5 and square with input 10. So when I called it with 5, I got the output as 25. When I gave the input as 10, I got the output as 100. Okay, and there is another built-in function called div mod. So what div mod does is it takes two values, say a and b, and then it will give me both the quotient as well as the remainder. So when 10 is divided by 3, the quotient is 3 and the remainder is 1, right? So div mod can be used to get both the quotient and remainder at the same time, right? So we can implement this div mod ourselves. Let's see how to do it. So I'm creating a function named my underscore div mod, and it will take two values now instead of one. I'm naming those as a and b. And to get the quotient, what we have to do, we have to do this floor division operation, right? So a floor division b will give you the quotient, and a modulo b will give you the remainder, right? And instead of returning a single value like last time, we can return multiple values from functions. I can say q comma r, and then that will give me a tuple of values as the output. So instead of calling div mod with the same 10 3, I'm calling my function now, my div mod. I'm getting the same output, right? So this is how we can create functions that can take multiple inputs, or it can function that can return multiple outputs as well. Here val is not defined, hence why there is no error about the same. Uh, where do you mean that? Val in square function? Okay. So your question is, here we are not creating within this function, we are not creating a val, we are not assigning anything to val like this. So when it is trying to calculate this, why is there no error, right? So what happens here is, so what we are saying is, when we are defining this function, what we are saying is, so when this function is called, there will be an input from the user, right? So that will be stored in the variable called val. So this variable val will be defined when this function is called. For example, when I'm calling square of 5, so what I'm saying is this value 5 should be assigned to the variable val, and then that value is used in the calculations within that function. Okay, so this variable val is created when this function is called. So at the time the function is called, so Python will create will do this basically, val is equal to 5 for you, right? So this is done by Python implicitly. And when you're calling it with 10, so val is given the value of 10 when it is called. So this happens when you're calling the function, that value will be created. Range 1 comma 2, can you repeat again? So that just was an example of how will you call a function, right? So range 1 comma 2 will give you just 1 as the output, right? So just I was explaining the syntax, how you would call a function. You would put the name, put the parenthesis, and whatever arguments that particular function takes, you will give that. So similarly, you can call your own functions as well. Okay, though function can return two values, can we store two returned values in two variables? Yes, you can do that. You can do multiple, you can unpack those variables. So what is happening here is, my div mod is giving you an output as a tuple, right? So there is a technique called tuple unpacking. So say if I say a and b is equal to my div mod of 10 comma 3, and So what here happens is A gets the first value and B gets the second value of the tuple. Right? So my do mod will return a tuple 3 comma 1, and here we are unpacking the tuple into two variables, right? So the first value A gets the first value 3 and B gets the second value 1. So that's what we are seeing here. So that is also possible. Okay. Yeah, so there are some few more things that we had seen in the lectures. So one is how to get descriptive stats like correlations, right? So Pearson correlation will get you what is the association. Is there a linear association between two variables, right? So one means two variables are positively correlated, minus one means they are negatively correlated, and zero means there is no linear relationship between the two variables. So those kind of descriptive stats you can get by using by calling the CORR, correlation function. Again, this makes sense only when you are using numerical variables. So what I am doing here is I am excluding the categorical variables. So similar to include, there is also this exclude parameter. So here we want to have only the numerical variables. So I'm saying exclude, remove categorical variables, and for the rest of the columns, calculate the correlation. So it gives you a correlation matrix, right? So for every pair of variables, so you get what is the Pearson correlation. So similarly, for the categorical variables, what makes sense is to look at the value counts, right? So how many values are there in particular combination of categories. So here we are working with the categorical variables, and I'm calling the value count. What value counts will give you is how many values are there in each category, in each combination of category. So we are working with fuel type, metallic color, and automatic. So fuel type has three categories: petrol, diesel, CNG, metallic color as 2 and automatic as 2. So there are all different combinations here, right? So there is petrol with metallic color, and transmission is manual. So there are 672 cars of those combination of categories. Then with petrol, no metallic color, and manual transmission, there are 322 cars, 323 cars, and so on. So it gives you for different combinations of categories how many observations are there in the data set. So that's that you can get with value counts. And then we also saw this cross tab you can use to get for two particular combinations of variables. So here we want to see between metallic color and fuel type. So between these two categories, how many values observations are there in each combination. So with CNG and no metallic color, 4 cars. Say with petrol and metallic color, there are 714 cars, and so on. So this way you could use the crosstab function. So this is from the pandas library again. So you specify what should be in your rows using the index variable index parameter, and what should be in your columns using the columns parameter. Then we looked at visualization, so different types of plots. So for plotting, so we'll use the Seaborn library. So first type of plot that we saw was the scatter plot, right? So for scatter plot, so you'll use this particular function. So from Seaborn, which we imported under the alias SNS, so the scatter plot function. And so we have to say what is the data set that you are working with. So it is a cars data set, and what should be on our x-axis, the name of the column, and what should be on our y-axis, again the name of the column. And so to display the, so when you call this, it will generate the plot, and to display the plot to the in the system, so you have to call the plot.show function. So when I do that, so what is happening is it is taking the age column from the cars data set and then putting that on the x-axis, and then it takes the kilometer column from the cars data set and putting it on the y-axis. And the scatter plot is nothing but for each observation, you will get a point plotted on the figure. So here there is one particular observation which has say 50,000 or so kilometers with an age of say around 11 or 12 months. Okay, so there is a 1 point for that particular variable, and so on. So we have, for as many observations, there will be as many points in your scatter plot. So this also can give you a quick visual idea of how these two variables are related, right? So what we can generally see from here, there is some positive association between these two variables. As the age of the car increases, the distance that the car has traveled also increases, which makes sense, right? So the more you have owned the car, so the more you have used it, and therefore the more distance has been traveled. So as we expected, there is some positive association that we are seeing here. So these kind of scatter plots will give you that. So the next type of plot that we saw, so here again, there can be some customizations made. So here what I'm doing is I'm adding another parameter called hue, which is equal to fuel type. So here I can color these different points based on some other variable. So I'm still plotting age, distance versus age, kilometers versus age, but now each point is colored based on whether it is a CNG car, diesel car, or petrol car, right? So that I can do based on the hue parameter. So hue will give you a different representation based on the categorical values that are there within that particular variable. And also, instead of say the name of the columns age and kilometer, I want it to be more descriptive. So I want it to be written as age, represented in months, and then instead of km, I want it to be distance traveled. So I can achieve this by changing the label names. So there are different functions in matplotlib that allows you to do this. So plt.x label, and then you can pass in a string. So that string will be used as the label for your x-axis. And similarly, there is a y label function which will allow you to change the y-axis label. And you can also add a title for the plot using the title function. Okay, so that's all that has been done here. Some customizations that you can add. So this is applicable for all the plots, not just for scatter plots. For any plot that you make, you can do these customizations. So the next type of plot that we saw is a histogram. So histogram is suitable for, again, numerical variables to see how the distribution, how the data is distributed, right? So here we are looking at the kilometer variable, and all you have to do is here there is only one variable, right? So there is no combination. So only the x variable is specified to be kilometer. So the y is by default taken to be the count, right? So what happens is it divides your data into some bins, right? So 0 to something will be some value will be one bin, and it says how many observations are there within that bin. Say 0 to say 1000, and then 1000 to say 2000, and so on. So some bins. So it's not equally separated by default, but it will divide it into some bins, and then it will give you how many observations are falling within those bins. So from here we can easily see that most of the observations are in this particular range, right? So between 50,000 and say 70,000, and there are very high extreme values, something close to 250,000 and so on. So this gives us a quick way of seeing how the data is distributed, right? Which regions, which range of values are more, and which range of values are less, and so on. Right, so here what I'm doing is I am customizing this his plot by specifying a bin width to be 500. So here what happens, I'm explicitly saying that each bin should be of width 5,000. So which means that from 0 to 5,000 will be the first bin, 5,000 to 10,000 will be the second bin, 10,000 to 15,000 will be the third bin, and so on. So here we can say that there are about 18 cars which have traveled between 0 and 5,000 kilometers, and so on, right? So this way you can customize the histogram plot, with respect to how many bins you are using. Yeah, and the other one is you can get a density estimation. So while histogram gives you the frequency, so the KDE plot, so this is using the disk plot function and specifying kind is equal to KDE. So this will give you the probability density function, right? So if you remove from your statistics course, so the PDF is a way of characterizing the random variables, and if you take the area under this PDF, that will be the probability of that variable falling within that particular range. For example, if you take the area under this curve between 10,000 and 15,000, so that will be the probability of a car traveling car to have traveled 10,000 to 15,000, or here 1 lakh to 1,50,000 kilometers. Okay, so you can get such PDF estimates using the disk plot function. And then for categorical variables, bar plots are more suitable for visualization. So that can be achieved using the count plot function. So if you again specify what is the variable in the x-axis, it will give you the frequency along for different categories, right? So in doors we had only 4 unique values, 2, 3, 4, and 5. And what we are seeing from here is there are more cars in our data set which have either 3 doors or 5 doors. So relative to that, the number of cars with 2 doors and 4 doors is lower in our data set, right? So this way we can visualize these categorical variables, and again we can use the hue parameter to differentiate it between with respect to some other category. Again here we are differentiating using the automatic variable for the hue, and what we see is there is not much difference for the automatic cars represented by orange, right? So they are almost the same when you look at 3, 4, and 5, even though 4 is somewhat lower, but the difference is huge when it is in the manual category. So among manual cars, they are mostly either 3-doored or 5-doored, but relatively lower number of 4-doored and 2-doored manual cars. Then the other way of looking at distributions for a given variable is using box plots, right? So box plot will give you again the 5-number summary that we saw in the describe function, right? The mean, median, standard deviation, the 25, 50, 75 percentiles. So those are represented here. So the number that you're seeing, the box that you're seeing here, right? So the lower edge of the box is the value corresponding to the 25th percentile. Then the upper boundary of the box represents the 75th percentile, and the middle line that you're seeing corresponds to the median value or the 50th percentile. And then these two are called whiskers, right? So the top whisker is you take the difference from the 75th difference between the 75th and 25th percentile, and then this whisker will be 1.5 times of that difference above the 75th percentile, and similarly this distance will be 1.5 times the interquartile range or the difference between the 75th and the 25th percentile below the 25th percentile. So anything outside of these, whiskers are generally considered to be outliers. That is just a thumb rule. It's not strict, it may not be strictly an outlier, but you have to look at your data. But in general, those are considered to be outliers. So that way you can get, box plot for distribution. And again, you can do this with multiple variables. So in the x-axis, I want to, have metallic color or not. So for those individual categories, I want the box plots for the price variable. And again, I can still customize it using the hue. So I'll have whether it is metallic color or not, and within that, whether it is CNG, diesel, or petrol, I will have different box plot distributions. And I'm looking at the price variables distribution for these different categories. And finally, so we'll look at how to deal with the missing data. So so far we have not done anything for the missing data. So if you call the isNA function on your data set, so what it will give is it will give you whether each value in your data set is a null value or not. Okay, so if you call isNA, so here we are seeing mostly false because most of the values in our data set is non-null. So here we are seeing a true, which means that this particular observation, so row index 2 under metallic color column having a null value, right? So it is true. So this way it will tell you whether each value in your data set is a null value or a non-null value based on true or false. If you want to get how many null values are there in a particular row, right? So you can call the sum function, on the output of isNA. Okay, so cars.isNA is your data frame of true or false, and then you can call sum, and then if you say axis is equal to 1, it will give you the row sum. Okay, for each row it will sum up these false and true, right? And by default false will be 0 and true will be 1, right? So that's why you are able to make the sum, and 0 means everything is false in that row, which means it didn't have any null values. And then 1 here means there is one null value in this second row, and there are some rows, say 1434 has 2 null values. So this way you can get how many null values there are there in each row. And if you don't specify axis, so by default axis will be 0. This means it will give you the sum for each column. So here we can see how many null values are there in each column. So price variable does not have any null. Age has 100 null values. Kilometer has 15. Fuel type 100 and so on. And these 4 variables do not have any null values as well. Right. So this way you can quickly see how many null values are there. So the same info is also available in the info, but in a different way. So info function will give you how many non-null values are there. So here we are seeing how many null values are there, right? So a complement of that. Right. So for the treatment, what we will do is, depending on the type of data, we will choose different ways of handling these null values. For the numerical variables, which are either the integer or the floating point numbers, we will try to fill those missing values using the mean or the median of those variable. And for categorical variables, we'll try to replace those missing values with the category which is occurring most times. Okay. So how can we get the mean and median? So we can get the mean of a particular variable by calling the mean function on that, right? So for the age column, the mean is 55.67, and for say the kilometer column, the median is 63,634. Now, if I want to fill those missing values, I can make use of the fill NA function. Okay, so I'm calling the age function, age variable, and I want to fill all the null values using the mean of the age column. Okay, so I'm passing cars age dot mean, so which will be actually 55.67, and I want all those rows within this variable where there are missing values to be filled with that mean value, and then I'm saving that back into cars age. Okay, because I want this change to be saved. And similarly for the kilometer column, I'm choosing the median, and I'm using the same fill NA function on the kilometer column, and then saving it back. Now for fuel type, because fuel type is a category, right? And I can get which category occurs the most using the mode function, right? So mode is nothing but the category or the value which occurs many times in your in that particular variable, right? So here petrol, as we saw earlier, is the most occurring category for cars. So therefore the output is petrol, right? So again, there could be multiple modes for a particular variable, right? So two modes or two categories has equal number of variables and maximum, then the output could be multiple here. So therefore to get the take the first value of that, so we are going to take the first index, which is 0. So we get the output as petrol. So now to fill it, again you have to use the same function, the fill NA, and instead of the mean or the median, we are going to give the value mode to be replaced, and with that way we are going to fill the fuel type using the mode. Okay, so instead of doing this, one variable at a time, we can again make use of loops that we have seen before. So here, say I want to select all the categorical columns. How can I get that? Is if I use the select dtypes and then exclude category, so then I get all the numerical columns. And if I want the names of those numerical columns, I can call the columns attribute. So this gives me the names of all the numerical columns in my data set. Similarly, I can get the name of all the categorical columns in my data set by using include category instead of exclude category. Okay, so this way I can get the names of a particular type of variables in my data set. Now, how can I efficiently do this? So here I'm making use of the for loop. So what this will give me is a sequence, right? Cars select details exclude category dot columns. So that is giving me this sequence of column names, right? And I want to do something for each of this column name, right? So this is a perfect use case for a for loop. So I'm creating a variable called column, so which will take the values of price, age, kilometer sequentially, right? So I can pass the variable name to select that particular column. So cars of column, and then fill NA with the mean of that particular column, because we are working with the numerical variables. I'm choosing the mean and then saving it back into the same column in the data set, cars of column. Okay, so instead of doing it for each variable separately, I have just written a for loop, and in 2 lines I can repeat this for all the numerical data types in my column. And similarly for the categorical data types, I can use the mode, right? Instead of mean, I'm using the mode. I'm using the same fill NA function to replace those. So if I execute this, So I have made a mistake somewhere. Yeah, I didn't select it, right? So I didn't give the index, right? I have to select the first index. Okay. So when I do this and then look at my data set again, so I have filled all the variables. So there is no null observations in my data set anymore. Okay, I think session has extended so long, but if you have any quick questions, I think I'll answer that. Okay, so if you have any questions, you can ask. If you have no questions, so feel free to disconnect and we can meet again next week. Can you repeat fill NA? Yeah. So fill NA, what it does is it takes a particular value as your input, and then it will replace all the rows in your column which has missing value with that value that you have given. For example, I'm just creating an dummy series here. Okay, so I just created a single column, okay, which has values 1, 2, and then there is one row which has a missing value, right? NaN. I want this NaN to be replaced with some other value. Say, let us say there is one more missing value. Okay, there are two rows which have missing values, and I want to be replaced with something. Okay, so in that case, I'll use the fill NA, and let us say if I give 5. So what happens is, so 1 and 2 will be unchanged because these are valid values, right? Only this NaN are your missing values. So it will fill those rows which has Na with the value that you gave. So now instead of NaN, you have 5 in those rows. So we have 1 5 2 1 5. So what we have done here is, instead of 5, we are instead of giving a single constant value, we are giving the value to be filled based on that particular column. We are choosing the mean value of that column or the mode value of that column as our fill value. That's all we have done. A dot merge dot concat. So that's for when you want to merge different data frames together. So maybe in the next session we'll look into that, right? So we have not covered that yet. A difference between a lock and iLock has already been covered. So maybe you can look into the recording and then find it. If you still have any questions in the next session, I'll answer it. Okay, so if you don't have any further questions, we can wrap up today's session. Thank you for attending. So look forward to seeing you in the next session. How to remember the syntax? Yeah, you just have to use it. So once you start using it, you'll remember it. So there's no particular way. As you keep using it repeatedly, it'll become second nature to you. Yeah. Okay, thank you.